Okay, folks, we've been talking about glaciers, and we're going to continue to talk about glacial deposits and glacial evidence in the past. And the best place to look for glaciation or effects of glaciers is to do it in modern rocks and then go look in the past and see what else you can find. So the number of things I'll just review here, but let's have a look at a few things. Like one of the keys here is abrasion. So you know the word abrasive. We use it on sandpaper. If somebody's enough of a jerk, we say they have an abrasive personality. You can imagine that underneath a glacier there would be lots of rocks that could be dragged along, and you can see here a fabric cutting across the fabric of this rock. So this material here is the schistosity of the rock, or the layering within the rock, and this material cutting across here is the glacial abrasions. So what's interesting is you can tell that this glacier was moving in this direction, either this way or this way. And you can use plucking to tell which way, as we'll talk about later, but that information is very valuable. For instance, when I was talking about how we knew the Gondwana existed, we could use the direction of glacial abrasions or glacial striations, which is essentially the same word, scratches in the rock, to tell which way it was going. If you go to Canada or Minnesota or much of northern Europe, you'll see outcrops like this that have been glacially polished. So this smooth surface comes about because a glacier came across and smoothed it off for us. Another thing you see is this neat French word, roche-montagnais, which has to do with sheep's back. Or some say that it's specifically talking about the lanolin in the sheep, and so it gets like greasy hair on the top of the sheep. Either way, the point of this is that on the upside, as you're scouring up, you are abrading the hillside. As you get on the other side, the steeper side, the downhill side, you are quarrying, freezing, and removing removing rocks from there. So it's abrasion on the upside and quarrying or removal of material on the downside. So you can tell which way it was going in that regard. Notice how there are lots of big boulder material being dragged along, some recently gouged out, and others that are just brought along to scratch the rock up. So there's a roche-montagnais. Notice how we've polished the backside and abraded it, and then we've plucked it on the downside, and the plucking leaves these sort of removal scars on the rock. So erosion by glaciers. Alpine glaciers erode mountain slopes into horseshoe-shaped basins called cirques. Melting forms Cirque Lakes, called a tarn. You can see these up in the snowy mountains. If we were going on the field trip, we would have gone up there to look at cirques and tarns, but I'll show you cirques because it's the key to the whole glacial story. Erosion or two or more cirques erodes the intervening rock. So you can have something called a horn, which is exactly that. It's been eroded away on three sides. And a arête, which is a long serrated ridge, like a steak knife. And cols, which passes through the ridges. So we better look at a picture of that. Okay, so the big difference between a valley formed by water and a valley formed by glacier is the V-shape of a water valley. So think about all the valleys you know in the world that were made by rainwater and rivers. They're all V-shaped. However, when you bring the ice down, it erodes on the sides much more, so you get steeply sided erosion happening. So you're cutting all of them away, so you end up with U-shaped glacial valleys. And I'll show you better shots of it, but here's a picture of a cirque, and a cirque, and a cirque, and these cirques, 1, 2, 3, are cutting into this thing to make an arête. But I have a better one to show you. Here's a much better picture. So the cirque is where we start the glacier, up here in the mountains, and as we keep piling more and more snow on that, it's starting to rotate it and gouge out material. And then as we replace it with more snow, it starts flowing downhill. So these are all cirque, 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 and these are cirque glacials, which come down and meet in a big one. And there's tributaries which all meet together, and so you could have a big main glacier that forms from a bunch of mini glaciers. If you take the glaciers away, we could then see an arête, steak knife, or cirques on each side of cut away. Tarns, which are little cirques filled with water. These are glacial lakes. A horn, where we've taken a cirque out of each side and made a pointy bit, and a col, where we've just had two make a little slice. Notice how then we have here a hanging valley, because this glacier here came along and cut this one off, And so you see beautiful waterfalls in glaciated terrains. There's a lot of beautiful landforms here, and if you ever go into a glacially eroded area, you'll see these everywhere. So here's Yosemite, famous for glaciation and for big granite batholiths and for waterfalls due to glaciation as well. So valley glaciers erode a large quantity of bedrock and sediment. They convert V-shaped stream valleys into U-shaped glacial valleys. Here's a typical one in Alaska. Notice the big U shape. Notice this pissy little river here trying to cut it back to a V. It'll take hundreds of millions of years to get back to a V because look at how U-y it is. Whenever you're in a U-shaped valley, you know it's been glaciated. So when the glaciers melt, then sea level rises and you end up with fjords. So if you ever go to Finland, Norway, they have very steep-sided fjords that you can take boats through, and they're very deep and they're very steep-sided. So they're different than normal places. Okay, so continental glaciers are different. These are the ones on land that are big. So erosional landforms much larger in scale than the alpine glaciers. You get whalebacks, which are really big, Roche Montanais. You get huge U-shaped troughs. And then you get a whole bunch of really interesting lakes, like the Finger Lakes of northern New York, the Great Lakes across the Midwest, all the way to the east coast of Australia, Puget Sound, Loch Ness, were all once stream valleys excavated by ice sheets. So here's a neat view of the Finger Lakes. They look like fingers. They're shaped exactly like glaciers. Here's the pre-glacial lowlands, the Great Lakes of North America, and I think I told some of you that the reason these glacial lakes are here, we don't call them glacial anymore, we just call them the Great Lakes, is that the weight of the glaciers pushed the mantle down in this place, and then when they melted, it's slowly rebounding, but it's doing so slowly it'll be millions of years and we won't be here anymore. But eventually there won't be any Great Lakes. So glacial deposits are what we often call glacial drift. The key to it is it's unsorted. So glacial till is a bunch of material that's not sorted by type or grain size. It's unstratified. It's just junk that the ice left. May contain glacial erratics. Wonderful word. Erratic being if you act strangely. We call it erratic behavior. If it's a rock that's sitting in the wrong place, has no bearing, no relationship to any of the rocks around it, we call it an erratic. So these are things that often accumulate at the glacier's terminus. At the terminus, we call it a moraine. That's a pile of glacial till that is left as the glacier retreats. So moraines may be reshaped by a later glacier advance into drumlins, which are simply beautiful rounded hillsides of till. Okay, so here's a picture of a bunch of moraines. Notice how the one here on the right is called the terminal moraine because it's the last one, and as it retreated back, which of course it didn't move backwards, it was still moving forward, but it was melting backwards. So retreat doesn't mean it's moving backwards, it means it's melting away. Notice how it leaves a series of moraines. Where I grew up, these were the only hills around me. All the hills around Chicago where I grew up are all glacier moraines. Because you can see here that in a moraine is just this pile of rubbish that's being pushed by the glacier up in front of it. So here's an active glacier. Here's a beautiful glacial erratic, and if you're anywhere in Minnesota or Canada, these things are everywhere, and these are simply boulders that have no business being there. So lateral and medial moraines, pretty much the same, except the lateral ones on the side, and the medial is ones that are dragged in between a couple of glaciers. So you can tell simply by mapping out where the glaciers were. Here's a picture from Kennecott Glacier in Alaska, showing you all of these strips of rubbish. These are moraines, these are lateral, these are medial. Just a few more here. As an ice sheet comes over and shapes these little piles of till, we call them drumlins. These are all over the Midwestern U.S. Here's in New York, a whole bunch of drumlins. So that we can have sorted material in what we call outwash, which is the material that's carried by water from the glacier. Loess, which is wind eroded. They say that the loess is what makes the Yellow River, the Yangtze in China, yellow. And eskers, which are sinuous meltwater deposits of sand and gravel underneath the ice. So here's what an esker is. As it's melting, you get these little channels of water that fill up with stuff, these little fingering things. And there, of course, is a beautiful esker. So effects of glaciation, They change climate, right? They depress continents, they drop sea level, and they make dams. And I'm going to end with that because I've gone too long with this video. Thank you very much.